In this video, beta-carotene is isolated from spinach by grinding the spinach and soaking it in acetone. The acetone extract is added to a column of silica gel, and the beta-carotene is collected using a mobile phase containing 9:1 hexanes to ethyl acetate. TLC is used to analyze the results. 0.5 grams of spinach was placed in a mortar and pestle, along with 0.5 grams of anhydrous magnesium sulfate. The magnesium sulfate should soak up most of the water that's present. 1 gram of sand was also added, which acts as an abrasive to help break down the spinach. The contents were ground to a paste and transferred to a test tube. 3 milliliters of acetone was then added and mixed with the paste using a spatula. This was then left to sit for about 10 to 15 minutes. In the meantime, a column was set up by clamping a large glass pipette to a ring stand. A small piece of cotton was placed in the bottom of the pipette using a wood stick, which will prevent the silica gel from falling out. Using a piece of whey paper as a funnel, the column was then filled with the silica gel. About 1.5 inches was left at the top of the column for solvent. A small amount of sand was placed on top of the silica so that when the solvent is added, the sand will buffer the impact and the even layer of the silica will be less disturbed. After the 10 to 15 minutes of soaking in acetone, the spinach paste settled to the bottom of the test tube and the acetone layer appeared to be black, at least until it was transferred. A few drops of the liquid was transferred to a small vial to be later used as a crude extract reference. The remaining liquid was transferred to a 50 milliliter beaker, and a stream of air was used to evaporate most of the acetone to concentrate the extract. The column was then flushed with hexanes to remove all the air pockets. A large pipette bulb was used to push the solvent through the column faster. Hexane was continually added in small increments so that the solvent line never got below the level of the sand. If it did, more air would just get back onto the column. At least 10 milliliters of hexane was used during this equilibration process. A stream of air, which may or may not be available to you at this time, was also used in lieu of the pipette bulb since it's a bit faster. Once the column was equilibrated, about 1 milliliter of hexanes was added to the concentrated extract. The liquid was then added to the column and partially pushed onto the silica with a stream of air. The beaker was rinsed one more time with an additional 1 milliliter of hexane and added to the column. An effort was made to get all of the green-yellow extract on the column in the least amount of solvent as possible, while I was maintaining the level of solvent above the sand. When the solvent at the top of the column became clear, larger portions of hexanes were then added. The silicon dioxide in the column works the same way as the silicon dioxide on a TLC plate. Polar compounds will stick more to the column than nonpolar compounds. Beta-carotene is a nonpolar hydrocarbon, so we would expect it to be one of the first compounds to elute from the column. Also similar to TLC, if we change the mobile phase to something more polar, then all of the compounds will move faster. After about 5 milliliters or so of the hexane was added to the column, a broad yellow band, which is the beta-carotene, was noticeable. To narrow the band and to get it to elute faster, the solvent was changed from pure hexanes to a solution containing 10% ethyl acetate, or 9:1 hexanes to ethyl acetate. After a few milliliters of this mobile phase was added, and as the yellow band reached the bottom, a separate test tube was used to collect it. If we wanted to separate and collect the other components, we could continue to incrementally change the polarity of the mobile phase by using 5:1 hexanes to ethyl acetate, 2:1 hexanes to ethyl acetate, and so on. These are fractions collected from a prior column doing just that. For this lab, though, we are only concerned with the first yellow fraction. So here is beta-carotene standard, the yellow fraction collected from the column, and the crude extract set aside earlier. 3 dots were lightly placed on a TLC plate with a pencil at the 1 centimeter mark. The beta-carotene standard was spotted on the first dot. Once it briefly dried, it was spotted again to make sure it was highly visible. The yellow fraction was spotted on the second dot. Since it was not easily visible, it was spotted several more times until it was. An effort was also made to keep the spot small. A better way to spot the yellow fraction may be to first concentrate it by transferring it to a beaker and use a stream of air to evaporate some of the solvent. In this case, the spot should be easier to see with only having to spot it once, and this should also keep the size of the spot small, which is preferred. The crude extract was spotted on the third dot several times. While this spot is easy to see, it contains several compounds, which will all show up better if it is concentrated enough. However, if any spot is too concentrated, it will likely smear as it moves up the TLC plate. After drying briefly, the TLC plate was added to a chamber containing 70% hexanes and 30% acetone. The TLC confirms, or in the very least suggests, the yellow fraction is indeed beta-carotene, which is also a minor component in the crude extract, which contains several other compounds.